Do you want to get really, 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 really good at Python? Because I have the thing for you. If you're a computing student or a programmer or like, I don't know, some random guy who just wants to get good at Python, I have some really good stuff for you. Here is my Python mastery guide, which is kind of what brings you from the level of Python that everyone learns because their dad tells them computing is the future, all the way to I guess actually being a Python programmer who knows how to like do stuff. So let's take a look at this. Firstly, list comprehension, one of my favorite things. You'll see this a lot in like answer keys, or that one guy in your class is just so good at computing you don't understand any of his code and he started using maps after day 2. I'm not talking about anyone in particular, but yeah, when you see code like this, you effectively need to know it's list comprehension. List comprehension is a way that you can write within lists themselves, right? A way for you to write within lists themselves without having to state every part of the list or use a loop, because the loop is inside of your list. So in here, if you have a bunch of numbers, right, 1, 2, 3, 4, 5, and you have +2, which is a list where every single value from numbers is taken, and they ask you to add the +2 value of it. Basically it says for x in numbers, which means for every value that's in numbers, put x + 2. So in this case, it would be 3, 4, 5, 6, and 7. You can do this for almost anything in list comprehension. Now we have conditional list comprehension, which makes it a bit more difficult to see, which is, let me just zoom in real quick. Sorry. Conditional list comprehension. Let's say we have numbers 1 to 9. X for x in numbers if x modulo 2 is equal to, whoa, what is that? Well, let's look at this one by one. If x modulo 2 is equal 0, which means x does not have a remainder when divided by 2. Which means x is even. So this means if x is even. So x for x in numbers if x is even. What does that mean? What happens when numbers checks if x is even? You will get the numbers in x. Sorry. You'll get the numbers in numbers, right? Where it's even, which is again 2, 4, 6, 8. So after you have the numbers in that list numbers where it's even, now you want to take every single value, right, and just plunk it into here. So you get 2, 4, 6, 8. It's basically saying for every single value in numbers that fulfills the condition of being even, plunk it over here. So now we have multi-conditional, which is again just an extension. This is just saying for every single value in numbers, if it is even, if it is greater than 2, plonk x there, which is why you get 4 and 6. Yeah, so it is a bit difficult, but if you master how to write inline, oh my god, your code is gonna look so nice. And then you have nested list comprehension. I don't even want to talk about this, it's that bad. But this is a way you can flatten matrices. Item for sublist in, matrix for item in sublist. Don't even try, but this is a way you can technically do it. Matrix being this, item for sublist in matrix. Let's break this down. Item is just what do you want inside of here, which means all of the values is item. For sublist in matrix, sublist is this 1, 2, 3, 4, 4, 5, 6, 7, that kind. So item for sublist, sorry, ignore item for sublist. For sublist in matrix just means for every single 1, 2, 3, 4, 5, 6, 7, 8, 9 inside of matrix, right? Inside for every single teeny item inside there, which is 1, 2, 3 inside of 1, 2, 3, 4, 5, 6 inside of 4, 5, 6, and 7, 8, 9 inside of 7, 8, 9. So let me repeat one more time. For sublist in matrix and for item in sublist. So for the mini list inside of the big list and each item inside of the mini list, put the item down here, which is how you flatten it, and you get 1, 2, 3, 4, 5, 6, 7, 8, 9. A bit difficult to understand, but hey, it's one of your cool Python things, so just get used to it. Now we have maps. So maps are interesting because you can perform a function on multiple things in a list using a map. So let's say we have numbers, right? 1, 2, 3, 4, 5. Getting very cheeky, inline way to like do this is to have a square function. And then squared numbers equals to map square bracket numbers. Well, you might notice square is a function, right? So you're mapping the function of squares to the list numbers. You're saying for every single thing in numbers, do square to it. That's what a map is. and then you store the final result in a squared numbers, or you can choose not to do that, it's up to you. And if you format it to a list and you print it out, this is what it's going to look like. Now we have typecast mapping. I highly recommend you learn this one because it's actually very useful. So we have this bunch of string numbers, right? Like 1, 2, 3, 4. Let's say you just kind of stole them off of like something. Then you want to turn them into ints. You can just put int because int is a typecast thing. You can just int a string, which is very interesting. So now you can just put int bracket string numbers and you've created your int numbers, which is really, really fast, simple, and nothing goes wrong. Now, this is a bit more difficult, which is data handling. So again, we've always experienced those CSV files where we have random stuff stuck in the front or the back that we need to clean. Well, you can do that really simply just by putting str.strip comma data, and the data being the list of just strings with random stuff and formatting inside of it. Again, it cleans it all in one shot. It makes everything simple, nice, clean, solid. Now for enumeration. Enumeration is it's iteration that allows you to access both its data and its index. Basically, if you do for index comma fruit in enum fruit or enumerate fruits, right? You will not just go through the fruits alone. You will go through the index as well as the fruit. So if you just put four fruits in fruits, right? You will be able to access fruit, and it will be apple ones, banana ones, and cherry ones. But here, by putting index comma fruit in enum fruits, you're allowed to access both the index and the fruit itself. So 0 apple, 1 banana, 2 cherry. And this is very useful if you want to, I guess, while in an existing loop, do something that you need to do again and again. So it just makes your life slightly easier. And then you can index lists this way, and then you can loop over dictionaries in a very similar way. So you can basically take all of the different pieces of data inside of a dictionary. So like for dictionary entry. So for example, name Jared, age 25, class 16S55, and combination PFME. You can kind of do that and then print it out. So it kind of makes sense. It's very easy. It makes it easy. Okay, here's the part a lot of y'all might want to skip, which is args and quargs. This is particularly difficult, I would say. Args and quargs allow you to take a lot of arguments. So if you print arguments and you put args, right? No matter how many arguments you pass in, regardless of whether it's 3 arguments or 4 arguments, you will print out all of the arguments, if that makes sense. So when you pass values in, it doesn't say, hey, you're missing a value, or hey, you need more values, or anything like that. It allows you to just infinitely pass as many arguments in as possible, and it'll just deal with all of them properly, which is a strong programming thing. I would say it makes a lot of projects easier, and I'm a big proponent of this. I love this function, but again, a lot of people don't like it. They'd rather just throw everything into a list and pass the list over, which again, respect if you want to do that as well. Now we have quargs, keyword arguments, which is a bit more odd because keyword arguments kind of work a bit differently from args. You're gonna see them primarily used in terms of dictionaries, I would say, personally. So in this case, all of these allow you to use dictionaries kind of like without having to worry about the number of parameters you pass in. The amount of arguments you pass in. Then, okay, this is a bit more useful. I would say I actually used this during A-levels a couple of times. Lambda functions. Lambdas, you can think of them as shorthand functions. If you're too lazy to write def, whatever, then you can just lambda, which is just a quick definition and a quick thing. So again, what is a function fundamentally? It is take an input, give out output. So in this case, you quickly define your input, which is x and y, and you quickly define your output, which is x plus y. So in this case, this is a one-liner that defines what add is. And now if I just put add 5, 3, it will give me 8 because it just knows what to do. So the good thing about lambda functions is that you can inline lambda for a map. What does that mean? You know how usually in map functions you can put a function and then what you want to do the function to? Well, in this case, if you're using a lambda, you can declare it inline, which means inside of your function itself, while they're literally asking for what is the function you want to use, you can declare the function right then and there itself, which is very last minute and very Victorian-like. So I like this a lot. So yeah, then immediate execution, yeah, again, you can just straight declare it inside of your print and get it done, which is really, really funny. So after declaring what your lambda is, you can just bracket the variables you want to use and get it done. It's so stupid, but it works. And yeah, it's interesting, I would say. Just keep that in mind. So then we have try and accept. This is my friend Ashton's like favorite thing to use because it tolerates absolutely anything we throw at it. But keep in mind, it's a very dangerous function to use because if you use this wrongly, stuff can blow up basically. So in this case, try basically means let's try to do this, and if an error occurs, let's print an exception. So this basically is a very cheeky way of getting things done. So let's say I try to do something that is illegal sometimes and legal sometimes. Like I try to divide a variable by another variable, and sometimes they're both strings and sometimes they're both integers. If they're both integers, it works fine, right? The division's done. And if they're both strings, an error would rise, which means that this block where it tries to do the thing, for example, fails. And then it goes to the exception and says, oh, please, it's a problem, something happened. And then you get to write your own error, so it kind of makes it nice, I would say. So yeah, specific error handling is a bit more interesting because you can straight up just declare what error it is that you want. So over here, right, in accept exception as my error, you are basically saying, okay, I know you have an error you want to scream at me, put it into a box and give it to me so I can scream at the user better. But in this case, you're saying, okay, I can scream at the user in the way I want to, okay? You don't interfere. If I want to say that you're an idiot for dividing by 0, I want to be able to do that without whatever weird thing you want to tell the user. So you can override that as well. Then you have multiple error handling. It's a whole zoo over here actually, and there's an else. The fact that there's an else should tell you quite a lot about how error handling works on its own. So just keep that in mind. Then we have yield, which is the last thing on here. Yield turns your function into a generator. If you have a function here and you want to just keep throwing out stuff, you can think of it like a conveyor belt of just random stuff. So you can yield apple, yield 1 to 3, yield 3.14, and it'll just keep doing that no matter how many times you generate it, which is, I guess, it's useful, but I don't like it really, honestly. So yeah, if you want to use a yield inside of a loop, you can do that as well. So yeah, you want to check divisibility for numbers in the divisors. For a number inside of the list of numbers, if the number is divisible, then you can yield the number, just throw it out, chuck it out there. Yeah, again, it's a interesting thing you can use, but you don't need to use these. So like I said, it's very similar for the rest. You don't need to use these, okay? You can program around them very simply, but using these gives you 2 advantages. 1, you save time, and 2, you look cool, and I think that's really important. So yeah, okay, I hope you enjoyed. Bye bye.